Welcome, everyone. It is our pleasure to have you on our webinar discussing risk in low-code, no-code apps development and showing you supply chain risk to illustrate these attacks, to illustrate these risks. We truly appreciate the time that you are investing in being with us. My name is Ursula Ron. I'm a no-code's marketing lady. And I can see that there are still some people logging in, but let's use that time already for some housekeeping items. This is your webinar. I say that from the bottom of my heart. We are doing it for you, and please submit your question for the Q&A session. We will really try to answer all of your questions at the end of the webinar. In addition, the webinar will be recorded and the video will be made available, I assume, early next week. Now, let's have a look at the agenda, what we have here for you today. So we'll give you a brief introduction to low-code, no-code development and the very specific challenges in this field. We will show you the supply chain attacks as examples. We will give you best practices and tips. And then shortly we will show you what no-code can do for you to help to manage supply chain risk. And then we have the QA. So now it's my pleasure to introduce Amichai. Amichai Shulman is CTO and co-founder at NoCode Security. And I'm challenged to put a huge career of 30 years into 1 minute. Amichai co-founded Imperva in 2002. Served as CTO at Imperva for over 15 years. Last week, Amichai celebrated 25 years of teaching cybersecurity and conducting independent research at the Technion, the Israeli Institute of Technology. Many top researchers went through his hands. So as we're going into the webinar, I will close my camera so I can address the chat and the questions that you are placing to us. And Amichai, could you please take it from here?
Thank you so much, Ursula, and welcome everybody. Before we dive into our topic for today, some credits are due to Uriel Kayam from our internal research team and the student from the computer science department of the Technion who contributed greatly to this research. Now, low-code, no-code applications and application platforms are gaining a lot of traction within enterprises, and especially rapid adoption of the technology among the larger ones. These are platforms like UiPath, Power Platform, Mendix, OutSystems, ServiceNow, and some others, and they help organizations accelerate their digital transformation programs. These platforms allow different business units and business users to quickly transform the manual processes in the organization into digital processes and allow them to create new exciting digital opportunities. And in fact, analysts predict that by next year, most of the new applications developed by organizations will use these platforms and these technologies. So this is certainly an issue to look into from the cybersecurity perspective. Now, the question is, what are the challenges of this new shift of technology, of behavior from the centralized software engineering processes into this kind of shadow engineering process across the organization? Now, the first challenge has to do with scale and skill. There are so many more people now involved in creating software and automations in the organization. So they are creating more and more of these automation of these applications, 10 times more than we used to see in organizations. It's done in a decentralized way across the organization by people who are not software professionals and by no means are software security professionals. On that we have to add the speed issue. The process is so fast, going from having an idea to designing it in the platform, creating something initial, testing it, working a little bit, and then with the push of a button, making it available to the entire organization and sometimes beyond the organization. The speed is just immense, and it makes it so hard for the governance and security people to protect and monitor the app lifecycle, especially given the fact that we have a tools issue. The traditional security tools and processes are not applicable in this domain, either because of the scale or because of technology issues. So take, for example, peer code review, which is a known practice for secure development lifecycle. You cannot conduct peer code review if you do not have skilled peers around you in the business unit to review the applications or the automations you're creating. And additionally, even if you had someone else in your business unit who's capable of doing that, that's not their job. Their job is very different. They're finance people, they are HR people, they are procurement people. They're not there to do peer code review. Take, for example, static code analysis tools. Now, these tools rely on having standard programming languages with well-defined, well-known definitions that they can now analyze. In the no-code, low-code world, we do not have code. We have some representation of the applications and the automation, which is not well-defined, proprietary, and it's not made public. So there's an issue of lack of tools in a world where applications are created in immense number at a tremendous speed. So this, of course, gives hackers an unfair advantage because we have an attack surface that is fast growing using the same vulnerabilities that we already know, like the OWASP top 10. Enterprise security struggles with this new domain, this new attack surface, because they do not have the processes and tools, yet the attackers already have the knowledge and tools in place to take advantage of the new attack surface and its vulnerabilities. And the reason is because SQL injection is an SQL injection, regardless of whether the application was created using standard programming languages or no-code, low-code techniques. It's the same SQL injection and the same exploit. Same for authorization and authentication bypass. So attackers have the advantage. They are there. And just to prove my point, here's a real-world example that we stumbled upon with one of our deployments, where we had a financial organization. They were using the UiPath automation platform, and they were automating core business processes, the process user transaction data. And when we analyzed their environment, we found that the proprietary business logic was exposed to the internet, and confidential access keys were at risk of compromise. The reason was that the platform users were unaware of some default settings of the environment that actually exposed their business logic. The security team had no visibility to the configuration and really didn't conduct periodical security assessment of it because they lacked the tools. And it turned out that some of the business logic that was exposed contained the oldest textbook mistake, which is hard-coded secrets within it, in this case, an API key. So from there, it's game over for the hackers. They have what they want. So we could go and look at more examples that we saw in the field, but what I want to do today is focus on one specific type of threats: supply chain attacks. And the reason I pick on supply chain attacks is because they are very easy to explain. They are, in fact, already part of the list of OWASP top 10 vulnerabilities for no-code, low-code. We all know them. Supply chain attacks are all about choices developers make and how soon does security team find out about these choices and review them. From the hacker's perspective, we of course know that there's this hack once effect that affects many victims with very low effort. So with that said, and the fact that all the platforms today have a marketplace for third-party components, encouraging their users to start up their automations or applications with community templates or components or widgets that were uploaded by other people, this is really a good point for an attacker or a hacker to start looking at. So let's take a look at a very simple example with a very simple choice. A developer that is exploring the use of a new package in UiPath, a package taken from the marketplace, and we've created this malicious package which implements some mathematical functions. And let's see what is happening here. We'll see that the developer is going to the marketplace and he's choosing the package that he's interested in, and that package is now added to the environment. Notice that immediately when the package is downloaded and added to the environment, the malicious code inside the package is executing. Now, in normal software practices, we know that when we take a malicious component and embed it in our environment, it does not take effect until we actually use it inside the project and until the code in the project actually executes. This is not the case here. In most low-code, no-code environment, when you decide to take a piece of third-party component from the marketplace into your environment, things start to happen immediately. And in this case, the code is taking over the developer's workstation inside the organization and can laterally move from there. Now, again, compare it to the situation with standard software engineering practices, where you have a centralized engineering unit and your malicious code finds its way into that unit only. With low-code, no-code, there are endless possibilities of where your malicious code can end up within the organization. It could be finance or HR or procurement or whatever. So we can see the immediate effect. We can see the expected result. And well, indeed, that was a very poor choice, clear one by someone. We can now look at some more development choices that are somewhat more subtle. And we need to understand that when development is distributed across many departments, people from different skill levels and different mindsets, they may make different choices. Now, what I'm going to show now is called dependency confusion attack. And it all starts with the fact that when you're dealing with third-party components, you're talking about package managers. And these managers assist the users with finding the right version of a package in runtime. So I'm saying in my project that I want a specific package, I'm saying which version, and then the package manager is making sure that at runtime I have the right version of the right package. It does that by looking into multiple sources or feeds that contain or potentially contain the package, regardless of what was the original source of that package. Now, mind you, that some of these sources may not be completely trustworthy and may allow people to upload malicious code, especially if these are public repositories. Now, in our example, we're looking at UiPath and the marketplace, and the package manager there is based on the NuGet framework. And it turns out that one of the default settings in the UiPath Studio environment is to allow using packages from the NuGet.org public field, which is not scrutinized for malicious content because it's a public field. Now, it's a choice of a user whether to leave this default or remove NuGet.org from the list of available sources, but you need to be really security minded in order to go and actually do that. So this is one choice. The other choice is when I attach a package to my project, I need to specify what version of the package I want. Now, I can set up a strict requirement saying I want that specific version, but some developers may make the choice of using a loose version requirement in which they say, well, I want at least this version, and if this version does not exist in any of the feeds, because, for example, it was too buggy and taken off, or had a security vulnerability and was taken off the feed, if it does not exist, find the next available version. Again, this is a choice by a developer. So with these two choices, let's take a look at the following scenario. Now, assuming that we have an environment in which public feed is configured as one of the feeds to look at, and we have packages and dependencies with loose versioning, and let's assume that some of these exact versions do not exist in any of the feeds, which is not uncommon. An attacker would now be able to upload into the public field a package with the same name, making sure that the version information inside that fake package is now just below the actual available version and just above the requested version in the project, which of course will make the package manager choose that fake package in runtime and bring it into the package for execution containing the malicious code by the attacker. Now, you would ask yourself, how common is this? So we went out and inspected all the packages in the UiPath official and marketplace. And it turns out that most of the projects in the marketplace, most of the third-party components in the marketplace and the official feed have loose dependencies. So they ask for the next available version of their dependencies. We further looked and found that 20 of these packages were potentially vulnerable because the exact version of the dependencies does not exist in any of the feeds, which provides an opportunity for the attacker to upload a fake version into the public feed. Luckily, well, not luckily, I think it was an intentional security choice by UiPath. They already taken over the UiPath namespace within the public feed. That's a possibility. So no one can actually upload packages with the UiPath prefix. So 16 of the packages cannot be exploited, but 4 packages in the UiPath official and marketplace feeds are actually vulnerable. So an attacker could potentially upload a malicious version into the public NuGet.org feed and have that version extracted in runtime by customer projects using these dependencies. Now, this is a behavior that can be easily observed and mitigated if you're using the UiPath, local UiPath assistant, or the UiPath assistant in a private cloud within your organization. But it turns out that the UiPath serverless robot platform, which is a cloud platform for users to run their automations in the cloud, is also susceptible to this same problem, and also include the public network feed as part of the list of feeds that is scanned. So this environment is also vulnerable, and it is more difficult in that environment for a user to make the choice of removing the public feed from the list of feeds that are being scanned. Now, after we've seen these two scenarios, we're going back to the question of how would a malicious package inject itself into the UiPath marketplace in the first place. They must scrutinize the packages that are accepted to their marketplace somehow for security issues. And the answer is yes, they are doing that. And as an attacker, I will need to outsmart them in order to do that. And I will use to my advantage this dependency confusion. So again, take a look at an example that we've created in our environment. So we created yet another mathematical package that computes Fibonacci series. And that Fibonacci calculator was completely innocent. It included only the Fibonacci code. And we published it through the marketplace for people to be able to use it. You can see we published version 1.01, completely legitimate. It went through the security scrutiny and got published. And when people are using it and introducing it to their project, nothing is happening. Wait an hour, and that same user that chose to use our package is now using this package for another project, or even re-executing the same project. And what we'll see, again, immediately when the user is selecting the package, the same version, the 101 version, we're seeing the malicious code being executed again. And the question is, how did we do that? How did we outsmart the security scrutiny process? And the answer is simple. We just created a truly legitimate package, and we made this package dependent upon a component from the public feed. So the first version of our package and the first version of that component were uploaded to the market feed, and they were completely innocent and passed through security scrutiny. Now, the dependency was a loose dependency. So now, after it was approved, we're able to upload a new version with an older version number into the public feed, and that component included the malicious code, which was immediately executed by anyone using this component without changing the version that exists in the formal marketplace. Game over. At this point, you're probably saying, well, these guys at UiPath, they're probably less secure than the others. And the answer is no. The reason I've shown you examples with UiPath is because we love UiPath and we work a lot with them. We're actually now formal partners with them, and they do care about security. But everything that we've shown is inherent to the low-code, no-code platform environment. And other environments suffer from similar issues that stem from developer choices. These are OutSystems and Mendix and Power Platforms. All of them have the same issues. Let me show you. So this is a quick example from Microsoft. One of the way you can use third-party components in Microsoft is through their connector infrastructure. And just a few months ago, Microsoft published a severe alert about the vulnerability in their connector infrastructure, which required all those who are using some of the connectors to go and manually make a change to the connectors in order to not be exposed to this severe vulnerability. Take, for example, OutSystems. They have their marketplace as well. It's called Forge. A lot of applications, samples, templates, widgets, whatnot. And it turns out that if you get a malicious component into the Forge marketplace, that component can create new users in the environments that choose to explore or use this component, even before it's introduced into a real project. Now, that means that the owner of the component, the attacker, gains access to all enterprise applications due to some choices made by the developers. Let's see those choices. So the first choice is obviously a bad choice, taking our malicious package from the Forge marketplace. That package has a simple flow logic in it that runs immediately when you bring the component into your environment, even before it is used in any project. And that flow just adds some users into your environment. Of course, the attacker, the owner of the component, knows the password for these users. Now, the next choice, which is very common by developers in the OutSystems environment, is to restrict access to enterprise applications, not by a specific application role, but purely on the basis of whether the user exists or not in the environment. So clearly, in this situation, when someone is introducing our component into their environment, we immediately get access to all applications that have made this choice of user access. Actually, that holds true not just for application users, but also for environment administrator users. The same trick can be applied to these users as well. And the question is, of course, how do malicious components make it to the OutSystems Forge marketplace in the first place? And the answer is, they're not really malicious. Take a look at this sample component from OutSystems that is posted to the Forge marketplace. And this sample component incorporates the same functionality I was talking about a second ago. So actually, by installing this component into your environment, you will be exposing your environment to users that their password is well known to everyone. And by the way, that's just an example of one way of introducing malicious component into these environments. Well, I think enough with the fun. Let's talk about solutions. So remediation is always going back to the basics. From the package manager perspective, you must make sure that you have the correct configuration. So use only trusted sources, restrict versioning to specific versions, make sure that this is across all your instances of package manager. In terms of using components, you need to enforce a policy across your organization that establishes thresholds for reputation of the packages that are being used, checking exposure to confusion attacks, tracking the changes and vulnerabilities for packages that are already being used in your organization, and then applying threat intelligence in order to detect those components that are already known to be malicious. So basically, we have a solution, but it's easier said than done, because applying this policy, this shift left security responsibility, meets the challenge of the unskilled citizen developers across all the organizations, where you have different employee types, organizational cultures, and departments with various priorities. On top of that, the applications are developed faster and in larger number, making it very, very difficult for the security and governance team to review each and every choice made by the developer across the entire organization. Now, if we zoom out and look at best practices, not just for supply chain attacks, but a framework for handling all local no-code security threats, it starts with getting visibility into your local no-code assets, of course, continues with monitoring the development and the process, and scrutinizing the individual applications and automations. And then it goes to remediating the issues and protecting the apps in runtime. And again, all of these in larger numbers of applications that we're used to, in faster development cycles that we're used to, and across a lot of departments in our organization. So the threat is imminent. Just taking one example of a threat shows how big the problem is. And while there's a blueprint for incorporating security into the low-code, no-code project, the scale does not allow for manual processes to succeed. If we try to do that manually, we are bound to fail. And this is where the no-code solution comes into place. We are introducing automation of security into the process of developing low-code, no-code applications and automations. First step is, of course, the discovery and visibility, seeing all your assets, getting all the information you need about your assets, including, for example, third-party dependencies. It then continues with setting the policies and rules to inspect the process and the applications created in this process. In this example, you can see some rules related to third-party components and supply chain attacks. And of course, detecting issues, and not just detecting them, but driving their remediation by communicating with the citizen developers across your organization, providing them enough information and clear instructions on how to remediate the issues, and do that in an almost real-time manner. So the value you get is knowing your organization's local no-code apps, detecting the vulnerabilities and malicious activity, and mitigating any security issues. Thank you.
Thank you ever so much, Amichai. That was quite a ride. So let's go into the question and answer session. So let me just have a look. I'm sorry, I'm having several screens here. There was a lot of talk about the decision as to choices, bad choices. So Roberta is asking that many of the problems are actually coming by the mistakes from the app makers, the citizen developers. So how does no-code can help with that?
So as I said, what we do is based on a policy set by the governance security team. We detect the issues inside the applications, inside the automations. An SQL injection is an SQL injection. You just need to be able to understand the representation of the logic in order to find them. And what's more, we're helping with the shift left process, which is not just to a centralized software development unit, but we're shifting it to all the citizen developers in the organizations, providing them the very detailed information needed to pinpoint the issue in their no-code, low-code environment, and instructions on how to fix it. Bear in mind, citizen developers really do not care what SQL injection is. All they care is, to do things right. If you tell them to do that one way or another and it gets the same functionality, they'll just follow the instructions. They don't need to understand what SQL injection is. And this is exactly what we're doing. We're providing clear instructions on how to do the same thing, but without the security risk in it.
Thank you, Amichai. Sam is asking that showing the different examples of the platforms, are some platforms more secure than others?
I can try and answer the question whether some platforms are more secure than others, and maybe try to count CVEs for each platform, but this is really not the issue here, because platform vendors are going to take care of these CVEs. What we're looking into is the mistakes made by the citizen developers when working on top of this platform. And it's a kind of a shared responsibility model here. The platform vendor says, I'll take care of the platform. So if there's a vulnerability within the platform itself that allows, for example, an external attacker to go from one tenant to the other, I'm the vendor, I'll take care of it. But if there is a citizen developer who is now creating a flow that takes input from an external form, does not sanitize it, and uses it for an SQL query, effectively exposing the system to SQL injection, then this is your responsibility. And this is where we come in place.
Mm-hmm. We have a question here from another question from Roberto. It's about the security stack. You mentioned at the beginning that this isn't working, is failing. Can you go a little bit even more into details? I think you actually answered that quite nicely during this show.
I can give another example to that one. And again, I'll have to go with what? Let's go with third-party component security, which was the topic of our webinar. And you have a number of tools out there that look into your standard software project and go over the dependencies and try to evaluate which one of those is actually vulnerable or not, or whether it's the latest version or not, and so on. You can name Snyk and JFrog and some others. And they rely on a very standardized format of these packages and the description of the dependencies and so on. When we're going into the low-code, no-code world, then each platform has its own format of describing the dependencies and their own proprietary fits where a lot of these dependencies come from. And you just need a different tool that is able to understand these formats, understand these fits, and work to get the information from there.
Mm-hmm. Thank you, Amichai. I think the next is quite an academic question. It is about the definition between low code and no code. There is always a lot of confusion about these two terms. And if you have something like working definitions for both of them.
So I have to say, as a practical person, we usually look at the market rather than the textbook definition. But I can say that what we focus on and where most challenges are, I think, is in what we call no code, where the developer never sees the actual programming language code behind the automation or the application. There are a lot of environments that were low code And what they actually do is help developers create their code faster. So you go and drag and drop and whatnot, but at the end of the day, you get a piece of code that sort of does what you've drawn on the screen. And from there on, you need to maintain the actual code. We're looking more into the environments in which you never see that source code. You always work through the high level representation of the logic of the application of the visuals.
Thank you, Amichai. Now, my thanks go to Graham. Amichai, I think you owe me a bottle of wine because I said there will be a question about AI. So here the question comes. Graham would like to know how AI will play out in these developments.
Well, I think that we already know the answer because most of the vendors out there have already introduced some sort of generative AI technology into their platform. And I think the immediate effect of it is just faster development with many more applications. Because even with no code platforms, there's sort of a barrier for creating your first flow, first application. There's something a little bit intimidating about it, even though it's all graphic and nice. When you have these copilots or assistants or chatbots that you tell them, I want to create an application on top of the employees table, which would have 2 pages. The first page is a table and the second page is a single record. And it creates something that you can now fine tune that breaks this first flow barrier and just allows everyone to participate in the game.
Thank you ever so much, Amichai. I think we are about to close the webinar. It's just about time. So thank you everyone for joining the webinar. Have a good weekend. And next week, early next week, you will get the recording and additional material. And thank you for your time. And Amichai, thank you as well.
Thank you, Ursula.
Bye, everyone. Bye.
Bye.